All right. Welcome back. Another week, another fine time for hacking around and playing with some code and building stuff and things. So if this is your first time tuning in, welcome. I'm Agent Ultra, and on this stream we program in Haskell. We build stuff in functional programming styles. We've been working on a project lately called LambdaTrek. It's a Trek-inspired roguelike. And I'm just going to give it a quick peek, see what it looks like. Open up a little terminal here. What our project is. Boom. Projects. LambdaTrek. There we go. And we run it with the stack command. Like so. Oh, for some reason we have to rebuild it. So the general gist of the idea is that you enter in these little commands and you control your ship using commands. The goal of the game is to destroy the invading force of enemy ships before you run out of turns. So this is your little ship here. This is like a little map of the current sector you're in. It's like a little local star system. We've got some enemy ships here and here. We've got some stars. We've got a space station here. On the side here, we've got an info map, like of your ship's status. There's your command input, where you can move around. Of course, we took some damage because it's a we take a turn, you take a turn kind of situation. So the enemies fired on us as we moved. We have all the damage and stuff, shields, phasers, torpedoes, all done. Then we have this galaxy map here. So you have long-range sensors. You can like scan sectors before you jump to them, or you can just warp right to them, jump, whatever. Like for example, 1-1 here. Looks like when we warped in here, already took some damage, and that sort of thing. So you get the idea. We're starting to get the game going now. It's starting to feel a bit like a game. And we just are wrapping up procedural generation. So these sectors are now populated randomly. I think we're just going to spend a little time tweaking that, make it feel a little good. And then we might be just tweaking some of the values in the game, making it feel good, and that might be it. And then we might want to look at either the next phase of the game or the next project for the stream. I don't know. We'll have to see. In the meantime, we got work to do, so let's bump over the code. Bump over the code. I don't know. People say that. Sometimes I just throw words around. Let's see what happens. Okay, so we're going to source LambdaTrek, and I'm going to check out the generator. Excuse me. So as we notice, there's quite a lot of enemy ships being generated. So I think one of the things we want to be able to tweak here are how many ships are going to randomly generate. And then just kind of tweak the placement algorithm. And I'm going to probably use something similar to what we did for stations. So I think we actually did that. Get rid of that comment. And we'll use maybe a similar sort of thing where we kind of go sector by sector around the galaxy map, and we kind of drop a random number of ships that we have remaining to place in there, see if we can place some, move on to the next sector until we've placed all of the ships. We just kind of go round robin like that. That might give us a pretty decent coverage and just kind of spread them out a little bit. It might cluster them close together. We might want to have like a maximum number of enemies in a sector kind of thing, so we don't dump them all at once. Alright, so we'll do generation enemies max. This will be maximum number enemies to place in the quadrant. And we'll do generation enemies sector max. Max number, shorten that to max, of enemies to drop in a sector to attempt. We're going to say attempt. That should be good. So. Okay, and let's go over to generate enemy ships here. So right now we're going, every sector is going to have enemies. And we're going to generate some random number of enemies for all the sectors. Oh, for each sector, we're going to generate between 1 and 4 enemies. That's not too bad, actually. But it felt like we got quite a few of them. We also want to limit how many in total we have, so I think we're still on the right track here. Yeah, yes. That's all going to be red. So let's actually start up the builder. So we'll use it through the test runner. We'll do fast, and we'll add the file watch. Like that. Okay. So it's going to go red because we just changed the structure. Generate state. I think we got to update generation state, the initial generation state that we pass in. Here. So let's start with, say, 20 enemies in total, and we'll try and drop 3 at a time. Okay, good. All right. Okay, so to generate the number of enemies we need, we're going to get that out of the state. So let's pull in generate state. And we're going to generate between 1 and state generation max sector enemies. What do I call it again? Enemies sector max. Sector max. There we go. Okay. Now we just have to respect the maximum number of enemies. So we need to know how many we've placed so far. So I might need to change up our top level function here from a traverse, where we're kind of going over every coordinate and doing this, to similarly what we do with generation stations, where we put in our count and we just go over the list of quadrant coordinates in kind of a round robin sort of fashion. So let's do that. I'll call generate enemy ships 0, and we'll cycle over the quadrant coordinates here. And so we'll pass in int. And then we go placed, or enemy count, enemies count. Right. We're gonna have to change this up a little bit. And then generate enemy ships. It's going to have a similar structure as well. Yep. So what I'm going to do is I'm going to actually rename this to place enemy ships. Yeah. And then it might not need that. We go generate enemy ships. And list of coordinates. State, generation state, unit. And if we have an empty list, then we just return unit. Otherwise, we have a station count. We have a, sorry, an enemy count. And we have a coordinate. And more chords. And similarly, I'm just gonna put a placeholder there. I'm gonna blob over this here, grab this, boom, jump back, boom, and we'll change that to enemies count. And then we're going to place enemy ships in sector chord, and then we go generate enemy ships, and that as well. Yeah, that way place enemy ships doesn't have to worry about it. We can just do our thing. Although we do have to tell the state how many we placed. So we're not placing just one here. So this should return a count of ships placed. And then this should be enemies count plus placed. Pull that over to the left a little bit. bet. So then when we place enemy ships, let's see. It's num enemies we need to return after we add them. Well, there's the possibility for add sector enemy to fail, potentially, if the sector is too full. So we should probably take that into account as well. Let's see, source, LambdaTrek, simulation, in... I think that's actually in quadrant. Yeah, that returns a maybe. Which we wrap up here. Add sector enemy. So we should really keep an internal count in this 4M when we've placed an enemy successfully, and then return the count of those successful enemies placed. So, in order to do that, we need to update this loop here. I think we can do 4. Because we don't want to throw away the results, but what is the result going to be? Let's see. If enemy placed. Count enemy placed. And change this. Count enemy placed is going to be a simple function. It's going to take a maybe enemy and return int. And if we have nothing, it's going to be 0. And if we have just whatever, it'll be 1. It's probably not quite right, is it? I'm just going to call it X for now, even though I know it's probably wrong. Yeah, that's going to return the last thing last. So what we want maybe is to traverse this, taking the sum of the results. Just meant traverse. Although traverse, I think, is flipped. The function comes first, which is kind of annoying. So, can I flip a traverse around? Right. This isn't quite the right operation because that's a thing. Can I just reverse the arrow here? Okay, so now X is not int, but it should be yeah, a list of int. So then we can take the sum of that. Let's call it counts or placement counts. Not the most efficient way of doing it, to be. We're going to be placing one between 1 and 3. Let's just see if it works. Okay. Because we could probably do this with a fold and just do the count incrementally rather than collecting these ones and zeros and then summing them at the end. And then the fold can take in and keep the result. However, it compiles. It's green. Tests pass. Let's try running it again. See how it looks. Oh, it's taking forever. I have to kill that. And that might be because we're not hitting our base case. We've got to update it too. Enemies max. And this is not right. Get rid of that. Get rid of that. That was silly. I should have spotted that. Yeah, it should be more like this, I think, right? When enemies count doesn't equal the number of enemies we've placed yet. Alright, so enemies count is carried by this function here in its argument. When this gets called, enemies count, if it's not equal to enemies max, we'll just say less than or equal to. Because we might not get exactly. And then we place enemy ships. So we might actually get a little bit more than enemies max here. It might be nice to do this exactly at enemies max, so... But we could do that, we can tweak that in a moment. Anyways, so that should place enemy ships. And when they've been placed, the placed count. Just call that placed count. Call it what it is. Placed count. Then we call generate enemy ships again with chords. Okay, that's better. Skaboosh. Yeah, not PowerShell. I should get this to default to the WSL terminal because I will never use PowerShell. It's only my streaming box. Okie dokie. Yeah, so stack. run LambdaTrek. If we're in the right project directory, that would be great. Cool. So let's see. Yeah, we got 1, 2, 3 enemy ships in this sector. Oh, actually, we got 4. Okay. I wonder if there's some residual hard-coded enemies still lurking around. Check that in a minute. Let's warp to 1-1. See what we got here. 1, 2. Okay. I'll go to 0, 1. 1, 2, 3. Okay, looking good so far. Sweet. Okay. Well, maybe some hard-coded enemy in that first sector there, left over from when we were just like testing things out, developing things, which we should probably get rid of. It's looking good so far. So let's just... Now we could probably, with this algorithm, get a certain number of enemies that are just a little bit more than the max. So we just got to be a little bit more clever with getting our enemy placement count in place enemy ships, the numb enemies. So what we should take into account the difference of the remaining number of enemies. Let's go. Actually, get rid of that. Just destruct the whole thing. Get rid of this here. Okay. So I'm going to take the maximum of 2 numbers. One of them is going to be generation sector max. And the other one's going to be the difference of the enemies placed so far and the current count, which means we need those enemies placed so far passed into us. And so there'll be generation enemies max minus enemies count. Just bring that over a little bit. There we go. Okay, so we need the enemy's count when placing enemy ships. Enemy's count so far. Okay, and we just have to use enemy's max here. There. And that should make sure that that is closed up. Okay, let's review. Okay, we have the enemy's max, sector max. And then we just update the generate enemy ships so that we kind of do the same sort of algorithm that we used for station placement, only we're placing kind of a dynamic number of stations or enemies rather than like one station at a time. And yeah, up to a max amount. The case, we changed the case to be when enemy counts is less than or equal to generation enemies max. That's just a safe defensive little measure. I think if we implemented it right, this should always trigger if we made it equals. But I'm just going to leave it there. And yeah, that's good. So let's commit that. When applied, this change will update generate enemy ships algorithm. We attempt to place maximum number of enemies across the quadrant by going around through the sectors and placing a random number, small number of enemies in each sector. Let's see. Actually, yeah, I'm gonna make this a work in progress because I just thought something. Let's not make it between 1 and an enemy's max. Let's make it between 0. So there's a chance that there's some relief in an empty sector once in a while. So replace. Let's just make it 0. Between 0 and watch that in, remove that, and that should be good. Cool. So the other thing I wanted to tweak was stars. We shouldn't have between 0 and 5. Let's have between 0 and 2 inclusive. Right, so we either get empty space or we get a single star system or we get a binary star system. Whoa, that is way more enemy ships than we should have. In a sector. Way more. What happened there? So I think that algorithm is not doing so hot for us here. Maybe we should have stuck with the traverse solution. That would mean we'd have to evenly divide all of the enemies across the sector, which we don't necessarily want to do. But this clustering is super bad. Maybe we need to keep track of how many enemies there are in the sector already before we go to place any. And if the sector has enemies already, then we'll skip it. The only thing is, if we add a ton of enemies to the map, like, we will be trying this forever, because we'll never reach our terminating condition that we've placed all of the enemies. We warp to 3-3. Can we get all the way there? Yeah, we're good. Mostly empty space. Mostly empty space. almost entirely... Well, that's got a star in it, at least. But yeah, we've somehow ended up, at least in this generation... Let's try and regenerate here again. Oof. I'm just using the long-range scanner here. We got 3 stars in here. That's not quite right. Or 2, 1. Our formula is quite wrong. Oh, so we want, we don't want max. That's what it is. We want, yeah. That's why I left the defensive thing in there. Right? Yeah, totally. Go me. That's a little better. Okay, we're still getting too many stars, though, but the enemy situation is much better. Good, good, good. So 2-2 has no enemies in it. That's cool. No enemies, no stations, just stars. Empty space. Interesting. Okay, okay. Good, good. Let's ship that. Okay, and stars. Hey Alice, how's it going? Nice to see you. Thanks for popping by. Okay, so 0. Num stars -1, I think. We are building a game. It's called LambdaTrek. It's a sort of a Trek-inspired roguelike game. And we're just working on the procedural generation part of it to generate the quadrant map that we play in. So this is what the game looks like. Oh, it's in the middle of building. Let's see if it runs now. There we go. So here we go. This is a sector map. The S is our ship. We got some enemy ships here in this sector with us, and a star. And this is like a tiny little region of space around a star, maybe a binary star, or maybe some empty space. And the goal of the game, anyway, is to take out the invading force of enemy ships within the turn limit. To do that, you've got this handy-dandy starship that has like some torpedoes, some laser thingies, and some energy to power all this stuff. It's got some shields and hull and stuff like that. And so the idea is you move in your command, you input your commands into a little command palette here. You can move around. We got combat implemented. And so it's a move, they move kind of situation. So we just move, no, it's the enemy's turn, and they just hit us. As we move closer, we can put our shields up. Now our shields are up, and that'll reduce the amount of damage we take, so on and so forth, right? We also have a map of the whole quadrant. So this is just one little sector that we're in right now. We have long-range scanning, so if we try to... It's numbered 0, 1, 2, and 3. We can scan like 1, 1. And we can see that there's some enemy ships in that sector, things like that. So if we're done mopping these cats up, we can warp over there and see what we can do. You got to keep an eye on your energy usage. You can't fire your phases while your shields are up, all this kind of other stuff. So the gameplay is starting to come together. We're just kind of tweaking procedural generation so that the quadrant kind of gets filled in nicely and makes it for a fun game. I think there's a couple little things, then we'll probably tweak some of the gameplay parameters, make it configurable a little bit so you can set up your game, how you want to play, change your difficulty, that kind of thing, and then, yeah. So going to be a endgame boss. You know, I haven't thought about it yet. Maybe. We could put a boss in there, we could... There's all kinds of things we could do, really. That's as far as I got with the game design, anyway. Take out the enemy ships before you run out of turns. We could probably add more enemy types, maybe a boss. If we want to really go down the quagmire with the game design, maybe we could even simulate more of the galaxy and add planets and mission givers at space stations, because we also have stations. We'll generate in this scenario like... Oh, we ran out of energy here, so we have our game over screen. Space stations where you can like resupply and get more energy and repair your hulls and stuff. You could have like quests and missions and stuff. That could be cool. Yeah, you know, it's kind of like the first cut of it. Kind of a smallish project, you know. So yeah, let's see, stars, that's good. And reduced number of generated stars. We're going with either single star or binary star systems for now. Okay, and oh, right, I needed to clean up something here. I think in the default generated game state quadrant, I might have hard-coded in an enemy. I might have been wrong about that, though. Yeah, no, that's in state. Ooh, gross. Just do a little consistency cleanup here while I'm here. Don't mind the white space, folks. Oh. Slip of the fingers. Bang. Yeah, we kind of like have a hard-coded game state ship in there. We should probably update that. Yeah, I should have an auto formatter set up for it with the way I like to format things. I'm a little particular about the way I format stuff in my own projects. I've taken this whole like to the left approach. Always kind of try and keep things to the left. Stay within your 80 column limits. And I find some of the auto formatters don't usually agree with me so much. And I should get into it because it's just annoying to have to do that by hand, but yeah, I agree. Yeah, I know. Once I have like an auto formatter in place, I don't really care, but I kind of prefer this style. Yeah, you think so? You know, I used to think Haskell was pretty ugly too, back in the day when I was first starting to learn. I'd come from like C and Python and JavaScript, but yeah, Haskell case took some getting used to for the types of stuff. And like records are kind of ugly in record update syntax. It's getting better. Kind of used to it now. White space indentation, like I got used to that with Python, so that didn't bother me so much. But yeah, it's okay. But yeah, once I have an auto formatter in place, I just don't care about syntax formatting as much. I would like it if it followed my style, but mind, whatever style is there. Okay, so I was just kind of poking around in here to make sure that I didn't leave a hard-coded game state number things. That's where we should get the parameter for the generation algorithm. Yeah, should hook that up. Yeah. Yeah, it's force of habit. I am pushing this one kind of public so people can get the code if you want to like hack on the game yourself or make your own version too, so that's why. I'm a bit of a stickler for it though. Let's see. Yeah. Okay, so that's actually one thing I wanted to hook up, was to make it configurable. We should either pass through the game config number of enemies into the generation state. Somehow, that would be good. Okay, so there's nothing there with a quadrant. Yeah, that would be in quadrant then. Init quadrant. Yeah, we got rid of the hard-coded enemies last week, that's right. So those aren't in there. This other one I use, Alice, is this work in progress kind of convention. So as I'm going, I commit a lot, commit quickly, commit frequently, and then I rebase stuff. And so I remind myself which ones I can rebase and squish into others. I can do like work in progress. I can commit like stuff that's like janky or broken. And then once it's fixed, I can squash it all down into something good. Which is handy when I'm like, I get stuck on a path in the code and I want to back out. I can just like kill commits and just pop them off to get back to a prior state, rather than have to edit the code back to a prior state. Yeah, pretty handy. Okay, so that's not in there. That's good. So let's do the game config thing and hook that up, so that when we kick off the generation, the procedural generation stuff, we pass in the number of enemies to do from this, and then we can write some loader type code that when it loads up the game or gets the game config by some UI screen or something. I don't know how we'll do that yet. And then I think the other thing we're going to want to do is set up the initial state of this ship. Start the game. Yeah, thanks for popping by, Alice. It was nice chilling with you. Okay. Yep. So let's see. Where did I build the generate quadrant? Right here. So I think what we'll do is we'll just game config as a parameter here. We'll pass in the config to generate quadrant. And then we'll just set config here. Now a bunch of things are going to go red and get mad at us. That's fine. Let's go update generate quadrant first. So we have to import the game config. Coming in from state. Apparel, import, LambdaTrek, state. And then yeah, we still want to do this to do as well. Thanks for past me for reminding myself of that. Generation state. So this is getting a little bit long, and this is why I like to stick to 80 columns here. Let's call let init generation state. I have to move it up. Yeah, let's make a function for creating the generation state. Generation state. And I'm going to put the game config in here. And generation state like this. And we'll pull out those things just on the left side of the arrow. You can use record wildcards. You can use record wildcards. That's the way I like to use it. Left side of the arrow. But if I was returning a game config, I would avoid the record wildcards. Generally because I find that the names would tend to clash, and that just gets annoying. So here we're going to create a generation state. And we're going to the generation state. We need the stutter gen. And we'll call it stutter gen here. Quadrants. We'll just use init quadrant. We'll pass it in. Call it quadrant. Sure. We'll make a quadrant. That sounds good and happy. Stations max. So this will come from the game config. Or it will eventually. We're going to just put 2 here. Enemies max. That'll come from the game config. State. Game config num enemies. And a generation enemies sector max. Yeah, we're gonna say like maybe 3. Might want to make that configurable as well. Although proper configuration of the game is gonna have to make sure that those numbers sort of depend on each other. That should be enough. So then we go back to yeah. Yeah, 2, 3. Yeah. So then we can go. Factory, you can put it here. Init generation state. All right, we're going to put in the config. We're going to put in our initial quadrant, which we're going to steal from here. After we put in our random generator. And then we can get rid of this. Put it in a state. Oh no, we have circular import. Okay, so we got to break up the circular import. I think this one's going to be pretty easy. We'll just create a new module. LambdaTrek big. And we'll pop over to state. And we'll grab the game config out. Pop it in here. And import here. And it generate. And then we gotta get rid of the state input here. Complete the circle. Okay, and then yep. So in the game setup, we gotta go pop over there. Fix up initial game state. Right. So we need LambdaTrek.config here. And Game config. We'll just say like 20 enemies. Game config, num enemies. And pass that in. Well, that should be. Oh, this is a different error. Sorry, a different module. In the game in the spec. Okay. Let's go fix the spec file. Barrow. So the initial test game state. Yeah, hardcode's config in there. So let's just import that because we changed the imports around. There we go, no problem. Config. Cool, thanks GHC. Sweet. Cool. And we're good. Let's go over the map. Oh, that's one man. Oh, yeah. Surrounded by enemies. Let's be on our sense range. Oh, yeah, yeah. Oh, there's a space station over there, so we can warp over. Sweet. Only one enemy. Ah, we can take it out. Let's put our shields up. Let's see. We should probably create a better map for this so this is numbered, so when you want to target your torpedoes, that'll be easier. So right now, this is like, what? 7 and 6. Something like that. Okay, cool. Let's see. Barrow. Yep. Looking good. Looking good. Generation state. Passing in the game config. So that we get the parameter for how many ships to do there. That's good. Okay, let's... Oh, entity module. Let's commit all of this under a work in progress commit. And let's see, add game config to generation quadrant, generate quadrant. Generate quadrant generation, now gets its stuff in there. Okay, so the other thing I wanted to add to this before I call that a commit is hooking up the number of stations. Okay, it's gonna red. So out of here, game config, num stations. Let's set it to 2 for now, like we have it elsewhere. We can go to generate. We can get rid of this magic number. Make sure we don't hard code that anywhere else. We get the generation stations max, yeah, perfect. Okay, so I'm thinking the test module probably needs that. No, I like the construction down here. Sweet. Okay, back there. And then, with that, add the number of stations to game config. Sweet. Okay, and I guess we might as well, while we're here, get rid of that last kind of magic number there in the init generation state. Enemies per sector. Number, max number needs to place per sector at a time during generation. Water generation.
Beings are uploaded or augmented. I don't think it's appropriate to call them human anymore.
This is the maximum number of stations to place. Okay, so this should be able to come from here. Game config, enemies sector. And then we got to go to LambdaTrek, set that here. Yep, and a spec. That should get us back to green. And it did, yay. Okay. That's good too. So let's commit that. Ax num enemies sector. And then let's see. Let's just have a default configure game config. And we'll basically take what we've been putting in here. Popping in that there. And we can just use default config here. Probably use that in spec as well. Sweet. Default config. All right. So let us rebase. We're gonna keep that one or reword it. Squash those into that. Keep that. Keep that. That's good. That looks better. Cool. Yeah, so I think that's pretty much what I wanted to achieve this evening. That's good. So we got random generation kind of working. Let's open our to-do file. Well, we still have to set up the player ship, I guess. We got generate quadrant done. I think that's kind of done. We didn't really need to do that to begin with. Well, we kind of do, but in a different way. That's just a little too random. Yeah, so how are we going to handle generating the player start? That's the next one. So let's see if we can dig into that a little bit. So the difficult part about that is that we're not going to be generating the quadrant per se for the ship. We're going to have to like take the generated quadrant, I guess, and maybe in a second function do the ship, because the ship is in the state a separate field from the quadrant. And the generator we've been working on so far for quadrants is just generating a quadrant. Yeah, so yeah, generate quadrant, right? Just creates a quadrant, returns the standard generator, which then we just kind of pass back into this game state, but the ship is separate from that. So I think what we can do is, this will be pretty straightforward, I guess, would be to Maybe have a function that takes the quadrant state. Maybe some function that takes the generated quadrant and returns the player's starting ship. And maybe the game config. So we might want to pass in stuff from that. What should we call it? Like generate player ship? Generate starting ship? For now, we can just focus on the position, and we'll just keep pretty much everything else about the ship as is, and then we'll, as we refactor it, we'll get rid of those magic numbers, set up the initial player's ship state. So the goal will be to get rid of this, and I'm going to pop it out, pull it out here. I'm going to put player starting ship here. And we're going to go and create a module and simulation for ship generate. Maybe we should just put in ship. We'll put in ship for now. And if we need to put in a submodule, we'll put in a submodule later. War factor stuff. We'll put it at the bottom here. Try starting ship. Takes a quadrant. Turns a ship. Okay, so we need to import quadrant. Hopefully we don't get any cycles. This is where we might need to create a submodule. If we do. Oh, okay, cool. We don't. Sweet. Okay, so from the quadrant, we need something else as starting ship. We need a random generator because we need to pick some sector to put the ship in, I guess. This returns the stud gen. I was going to take a stud gen. Already we can see that we're going to need to potentially refactor this as well. And move that, probably that, or a state monad up around this, perhaps. So this should need return a ship and a standard generator. And it needs to take in a quadrant standard generator. Okay. Cool, cool, cool. So then we hydrate. Now we need to pick. Okay. So we need to pick one of the valid sector coordinates. Oh, we need to actually implement available space. Keep forgetting. Let's add that to the to-do, the actual top-level to-do file. Oh, we have it. Okay. I just have completely missed it, and I should do that. Anyhoozle. Get sector, update sector. Okay, we don't list it there. I'm just looking for more cohorts. Quadricords. Okay, it is quadricords. Yeah, so for each of the quadrant coordinates, we're going to pick one of the quadrant coordinates, basically. So generate had a handy function for kind of doing that, but it was in state. Just come there. But we can kind of, sort of, use the same idea. This is going to get step gen. We step gen. And then we get step gen prime. Now, no. These is the in between the numbers. Oh, we're gonna do it. We're gonna do this. We're gonna do this. We're gonna do this. 0 between 0 for the x and y. Zero and 3. Quadrant y. There. Uniform R 0 to 3. Step check prime. Then we can paste off ship. No. Catch up with me next. There we go. Now we'll just pop these two numbers off. This will be quadrant X, quadrant Y. Oh, and the gen prime. There we go. It's ugly, but it might work. We actually use nothing of quadrant here. So we actually have to use that. Right, because the ship position X and position Y is this position technically, I believe, within the sector. And the position, the quadrant you're currently in, or the sector you're currently in, is in the game state. And a poorly named target here. So this isn't quadrant X. This should be like potentially. What is kind of quadrant X? Yeah. So we want to get the sector out of the quadrant. That's what we need to do. Then, once we have that sector, we can get the available spaces in that sector. We can pick one of those, and then we can set the ship's position there. And then, the other part of this is going to be this annoying bit here. What to do about that. I think what we're going to want to do maybe is has a lot of depending data where we're kind of throwing back and forth here. Yeah. Ooh. I think we're going to want some kind of stateful state function again here to do this. That's what I want. Yeah, because I want to be able to generate the player starting ship and set the state sector and stuff all up without having to like pass around a bunch of parameters through these functions. Otherwise, I gotta change this to a thruple. Make this an int. Which isn't too bad. Not great. And then we go here, player quadrant. This would be quadrant X, quadrant Y. The nice thing about this, though, with our invariant on sectors, is that there will always be an available space in the sector, so we won't have to, like, try a different sector if there's no space to put the player ship here. So what are we going to do now? We're going to get the sector coordinates. So we're going to get the sector out. Okay, sector. We need the whole quadrant. And we need our quadrant X, quadrant Y. Okay, now that we have the sector, we need to get the available spaces. I think we have that already. We got tiles. Find empty. This finds the first empty space. We should have get empty. Turn int, list of intents. Alright, get empty is going to be very much built on socks and get sector tiles. And instead of filter, Well, we do need the filter. Because we only want the empty spaces. Let's clean this up while we're here. But instead of taking the head and the first, we're just going to go right to Xtcord. And we're defining it twice, so I guess we might as well make it a top-level kind of function. Let's just get this going first. This is even the right function, I don't know. Alright, we need a map first. Map both of these. Let's get empty. Boom. Throw it up here. Okay, Xtcord. I'm gonna just pop that out because it's the same. Okay, and then yeah, we're back to green still, but we're going to use that now to get the empty So we got to choose one of those empty things. So we'll go like sector space, sector coordinate, forward. We're going to do something with, it's probably going to be sector coord and studgen. Something studgen. And sector get empty of sector tiles. Yeah, we're gonna pull this in. Simulation dot sector. Yeah, okay, so now our empty hole is gonna be like our kind of cheapy version of choose. I wonder if there's something in system.random that does that already. System.random. Let's see. Random. Ba-ba-bum. Yeah. We generate numbers, but we're not gonna, there's not gonna be a pick function. So we're gonna have to write our own little pick function. I have a feeling that I'm gonna refactor this to use kind of the common state AE tools. We got import cycles, of course. Okay. Alright. So we're gonna have to put this into submodule already. Module LambdaTrek dot simulation diff dot generate. There. Maybe system dot random. We're gonna need a sector and quadrant. And we're gonna need our handy dandy little function we've been writing. Let's see. Oh, we still got one. So we have removed cycle from here. I think we need any of those now. Oh, we're still gonna have the cycle though, aren't we? Oh, maybe not. No. We might have broken it. Yeah. Okay. Just a couple of small normal things. We need record wildcards. Language. With a capital C, please. And then state just needs to import from our generate step. This is where we might bring in that import cycle. Oh, okay, good. Sweet. All right, so this is the function we need to implement. Instead of AB, though, we're going to be making it int. Although, technically, it could be AB. But the list could be empty. We'll just make a list of A, and it'll be just maybe A. So if you give us the empty list, silly, we'll do nothing. Otherwise, pick something from it. Let's see, we can get our maximum, our uniform R, element, and our studgen prime, index, sorry. Uniform R between the 0 and the length. X is -1. Because I think it's inclusive. Maybe it's not. Check. Uniform R. Yeah, inclusive in the lower and upper bound. Okay, so we do want to do -1 there. And random generator is the second argument, so go studgen there. And then from x's, we're going to x. I'm going to do just. Okay, so then we pop pick in there. Now it returns a maybe a, so it actually needs to return a maybe a standard gen. Boom, 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 boom. And then this becomes a maybe, so we'd have to like pick this apart as well. So I'll do case. Of nothing. And just so what do we turn in the nothing case? That's kind of odd. Yeah, if I am a good Haskell citizen, I'm not gonna make that an incomplete impartial function. I could force up the constraint that if you can prove this is not empty, then we can get rid of the maybe. That makes this function have to handle that case before passing in the sector tiles. So get the empty tiles is going to have to prove that it's not empty. So we still have that case handling that has to happen here. Boo. Boo. Let's see, burp, burp. So prime. Yeah, kind of dirty. Kind of dirty. Let's just make it kind of gross and dirty. Let's put it in there. Quadridex. Okay, so now we have sector coords for the ship. Sector coord X and sector coord Y. Change those. And stud gen prime. Okay, let's see here. And we don't need to actually use a record wildfire here, so let's get rid of that. Okay. That's good. Let's go back to... Well, I mean, it's not great, but it is what it is. We'll clean it up eventually. Let's see where we're at here. Compiling-wise, we're back to compiling. Okay, let's try it out. Should we go to our map here? Where are we? Oh, we haven't set that up yet, so we're not quite done yet. We go to generate ship. Okay, we go state. No, we set the player quadrant. Yeah. Starting ship. Chord X, chord Y, quadrant X, quadrant Y here. Interesting. Okay, so our current sector is 1-3. Okay, so we still technically have another to-do item here, which is to set the initial scan state for the quadrant map. So if we start the game again, we should be in a slightly, a different random sector. Here we spawned right next to an enemy ship. Cool, cool. Yeah, and if we run it again, we're just gonna... Okay. So the next thing we need to do is just set that initial scan state. But I think we're out of time on the stream tonight, so I'm going to commit this. And we're going to clean this up next week. I'll push it up on the bridge, and it's kind of work in progress for him. I generate ship. This places the player ship in a random sector and random available position within sector. Okay, so our to-do. It's done. So we need to set the initial quadrant scan state. Cool. Right. Looks good, looks good, looks good. Let's push it up. So this is your first time tuning in. Welcome. Thanks. It's been a pleasure coding with you and hanging out with you. All the code you've seen tonight for LambdaTrek, the project we've just been working on, is here on GitHub. I'm Agent Ultra. The project is LambdaTrek, so it's Agent Ultra / LambdaTrek. And you can find the code there. Check it out. Watch it. Star it. Hack it. Do whatever you like. Learn from it. Or not. Learn what not to do. Who knows? And yeah, you can follow me on the Mastodons, of course. I'm on the Twitterverse, Twitterverse, Mastodonverse, Fediverse. That's the one. I'm on the Fediverse. I'm on the types.pl server. I'm Agent Ultra there as well. And you can follow me there to get updates about the stream and other things I'm working on. You can find all my links to my other stuff. If you're watching on YouTube, there's my YouTube channel. Or you're here, go to the Discord server sometime. There's a link to the Discord server in the link above. And then you can chat between streams there if you like. You can also like do the subscriptions and the followings and stuff like that on Twitch or on YouTube. Set up those notifications and you can follow along there. 'Cause sometimes I do these streams kind of randomly, but usually I stream. My main night is on Tuesday evenings in the Eastern time zone. So if you want to get notified when I go online the next time, do that or not. That's my usual schedule. And yeah, I guess we will see you next week at the same time. It's been a pleasure. Thanks again for watching. May your monads be free and your types always check. I'll see you next week. Bye.